Here we've got problems 18 and 19 on the equilibrium review. For 18, we have an object that is being pulled with a force of 43 newtons. We do not know what angle it's being pulled at. We know the normal force goes up, gravity goes down, friction goes left, and we know that's 27 newtons. And we know that the mass of the object is 18 kilograms. If I try to solve for the force of pull in the y, force of pull in the x, I don't have the angle. So I can set it up, but I can't plug it into my calculator just yet. Force of pull in the x is the adjacent side, so it's going to be the cosine of wherever that angle is, times the pulling force, which is 43 newtons. Force of pull in the y is the opposite side, so I know it's going to be sine of the angle times the force of pull, which is 43 newtons. All right, we know there's no acceleration, which means all of our rightward forces, force of pull in the x, has to equal our leftward forces, which is force of friction. So force of pull in the x equals force of friction, and force of pull in the x is cosine of the angle times 43. Well, we know what our force of friction is. Our force of friction is 27, which means that I can divide 43 over to the right side, and I would have friction, which is 27, divided by 43, and that's going to equal the cosine of my angle. But I don't want the cosine of my angle, I want the angle itself. So to get rid of the cosine, I have to do inverse cosine. So the angle itself is found by doing the inverse cosine of 27 over 43. And when I plug that into my calculator, I get 51.1 degrees. Finally, number 19, here's an object, and we are trying to find the normal force. We are trying to find the force of friction. Again, there is no acceleration, which means that everything to the right, friction, equals everything to the left, gravity parallel. Everything up, normal force, equals everything down, gravity perpendicular. You know the mass of this object is 1,500 kilograms, and it's on a 10-degree hill. So since right equals left, I know the force of friction equals force of gravity parallel, and force of gravity parallel is the sine of the angle, 10 degrees, times the mass, 1,500, times g, 9.8. So I plug all that into my calculator, sine of 10 times 1,500 kilograms times 9.8 meters per second squared, and I find that the force of friction must be 2,552.6 newtons. In the up and down, normal force is up, gravity perpendicular is down. They have to equal one another. So the normal force equals cosine of 10 degrees times mg, because that's the equation for gravity perpendicular. So cosine 10 times 1,500 kilograms times 9.8 meters per second squared tells me that the normal force is 14,476.7 newtons.